So hello everyone, welcome to this channel. So today we are going to discuss a very important topic, that is the degree of freedom. It is one of the most important topic in the chapter of simple mechanism if we talk about the theory of machine. So firstly, if we move into the definition of degree of freedom, we can say that it is the minimum number of independent variables which are required to define the position or the motion of a system. Suppose if there is an object, let's take this example. Suppose here is an object. So if it is free to move, then either it will move into the x-axis, into the y-axis, or into the z-axis. Or what it can do, it can rotate about this x-axis, it can rotate about this y-axis, and it can rotate about this z-axis. So what is the total number of translation as well as rotation motion? So we can say that 3 translation in x-axis, translation is y and z, and similarly 3 rotating in x-axis, rotating in y-axis, and in z-axis. So total 6 motion are there. Now what is degree of freedom? For example, if we are restricting it in a particular way, for example, we are not allowing it to move into the x-axis, then what will happen? We are restricting it in its x-axis. So that is our restraint, or that is our constraint. So then what will be the degree of freedom? It will be maximum motion, that is 6, minus the one which we are restricting. So 6 minus 1, then the degree of freedom will be 5. For example, if we are not allowing it to rotate in x-axis and we are not allowing it to move into the x-axis, so 2 motion we are moving considering as restraint or constraint. So then we can say that 6 minus 2, that will be equals to 4, then 4 will be its degree of freedom. So this is very simple. Now that is the case of 3D. Similarly, if we consider, or if we want to know about 2D, then what will be the case of 2D? It will be same, but in 2D there is only 2 axes. One is the y-axis and the other one is the x-axis. So in 2D there are only 2 things. Either it will move in the x-axis, it will move in y-axis, or it will just rotate in the xy plane. So maximum motion possible in 2D is 3. Now if we restrict it in one way, then we can say that 3 minus 1, then the degree of freedom will be 2. If we restrain it in 2 ways, suppose we are not allowing it to move into the x-axis, neither we are allowing it to move into the y-axis, then our number of constant or restraints will be 2. Then at that case the degree of freedom will be 3 minus 2, that is equals to 1. So this is very simple concept. Now we shall understand that how to find the degree of freedom for any particular question. So for that purpose we have the Kurzbach equation. So what is this equation saying? Simply if we consider the formula, then we can say that degree of freedom will be equals to 3 into L minus 1 minus 2J minus H. Now this denotation can be different in different books. For example, we are denoting L. L stands for number of links. So for a particular mechanism, the number of links, that we are denoting it here as L. Now minus 2J. What is J? J we are considering number of binary joints. Okay, binary joint means the joint between the 2 links, that is known as the binary joints. And what is H? H means the higher pair. So what is higher pair? Higher pair means that if the 2 links are making a point contact between them, not a surface contact. What is the difference between surface contact and point contact? I hope you know this. So if the 2 bodies are having the whole surface in contact, then that is the surface contact, and if one point is in contact, then that is the point contact. So higher pair means those pair which are having the point contact is known as the higher pairs. Okay, so L is the number of links, J is the number of binary joints, and H is the number of higher pairs. So only this is the Kurzbach equation. Now one note point is there that in some question there will be FR. So what is FR? So now this whole equation is becoming the modified Kurzbach equation. Initially Kurzbach has given this equation, but later we have derived this formula also, that in some cases there is FR is coming into place. Now what is this FR? FR means redundant link. So I have also mentioned it here that what is redundant link. For example, there is a mechanism and there is a link in the mechanism whose motion is not affecting the motion of the mechanism. Now if you don't understand, then don't worry, I have an example for you. So let us find the degree of freedom for this particular problem or this particular mechanism, right? So how to find the degree of freedom for this? Now see, first of all, what is the number of links we are counting? See, whenever there is a fixed link, we will consider that link number 1. So here two fixed links are there, one is here and the other fixed link is here. So both the links we are considering it as 1. So this is the first link, number 1. Okay. Now this is the link number 2. Okay. Now here is a cam. So here it is a rotating device. So we are considering this link as 3. And here is the follower. And so we are considering this link number 4. So total 4 links are there. I hope there is no confusion in that. So L equals to 4. That is clear. Okay. Now what is J? Where it is the number of binary joints. That means whenever there is a surface contact, so that is making one binary joint. Now see, there is a surface contact between 1 and 2. Okay, the whole surface of 1 is in contact with 2. So it is surface contact number 1. Between 3 and 4 there is another surface contact. So it is surface contact number 2. And between this 1 and 4, this fixed link and this follower is moving through it. So it is surface contact number 3. That means there is a 3 binary joints are there. Okay, I hope it is clear. Okay, now what is H? H means higher contact. I have just told you that what is higher contact. Whenever there is a point contact, that is known as the higher pair. So see, between 2 and 3 there is a point contact. So this is the higher pair. So here H equals to 1. Fine. Now what is FR here? So see, what is FR? I have just told you that redundant link means whose motion is not disturbing the mechanism. See, this is the cam here. Now if we rotate this cam, okay, if we rotate this cam, you can see that with this rotation the whole mechanism is not going to disturb. It will just rotate on its own. Okay, but not in case of any other. See, if we just translate this 4, it will disturb the mechanism. If we want to rotate this link number 2, it is not possible, but if still it is rotating, then it will disturb the motion. But only 3 is that link which is the redundant link. If it is rotating, then it is not going to disturb the whole mechanism. So here 3 is the redundant link, and so number of redundant link is 1. So now what is the formula? 3 into L minus 1 minus 2J minus H, okay, minus FR. So FR will be here 1. So 3 into 4 minus 1, that is 9, minus 2 into 3, that is 6, minus H means 1, minus FR means 1. So 9 minus 6 minus 1 minus 1, that will is equals to 3, minus 1 2, minus 1 1. So if somebody asks you that what is the degree of freedom of this particular mechanism, so we are going to say that the degree of freedom for this particular question is 1. So I hope this video is helpful for you. If you have still any doubt, you can ask me. I will definitely try to help you. So thank you for watching. See you again. Bye.